So students, the formula of power was your work by time, and the unit of work you have calculated previously is your m L square t to the power minus 2, and the unit of time is t. Why? Because t is your fundamental unit. So this work, the unit of work is divided by t, the fundamental unit. So what will be the final result of the power? It will be m L square t to the power minus 3. Why? Because see, in the previous step you had, I am writing it here. I am writing the case of only t here just to make you understand. In the numerator you had t to the power minus 2 and the denominator just t. So when this t will move up, it will be minus 1. So minus 2 minus 1, how much? Minus 3. So t to the power minus 3. See, I have written it here, isn't it? So your final formula of finding the power is m, or final unit of power is m L squared t to the power minus 3. Okay. Now we have learned so many units of power. Let us just discuss a simple unit. Another unit, let us consider the area. What is the area, students? It is a square of the length. That means since I am using the term square, so L will come twice. So L into L is how much? It's just L square. Isn't it, students? Okay. And it is using only one type of fundamental unit, that is the area. So students, we have seen so many units, how these derived units are using the fundamental units and how they are varying. Okay, how they are related to one another. Okay. Now students, you can ask me that whether all physical quantities have dimensions. The answer is no. Physical quantities are available without dimensions also. So let us learn more about it. It is known that a number is dimensionless and a physical quantity is expressed as a ratio between the two physical quantities of same unit. But number, and it becomes number only. Okay, so let's discuss about this particular statement. You all know that a number, do you find any unit beside a number? A number is completely dimensionless, that means it has no dimensions at all. So when a physical quantity is expressed by the ratio of two same physical quantities, suppose I am taking the take the example of this. Suppose you are having the unit like L by L or T by T, anything, same units in both numerator and denominator. Obviously it will become 1. Same, you are dividing the two units of same quantity, so it will be left with only 1. So this is what the physical quantity without dimension means. Okay. So now take an example. Okay, let me wipe it out. Let us take one example. Okay. So suppose take the example of mechanical advantage of a machine. I hope you have heard of the name mechanical advantage. I am writing it short as M.A. So mechanical advantage of a machine is expressed by the ratio of two forces. In this book also will be learning more about these simple machines, and here also will learn the mechanical advantage. But for the timing, you think that mechanical advantage is the ratio of two forces. So since it is the ratio of two forces, suppose F is also here, and F1 is present and F1 is present, F2 is present. So if F1 and F2 are present in numerator and denominator, more or less they are the forces, more or less they are the forces. So when F is present in the numerator and F is also present in the denominator, so they will cancel out and you will be left with only one number. A number will be there, any number. Isn't it? Some number will be there, that means whatever number will be there beside this force, that number will be there in the final step, isn't it? Because all the forces are getting cancelled. Okay, so the result will be a number which cannot have any dimensions, as I told you previously. So let us take another examples. That means that is your example 1 of physical quantities having no dimension. For your first example was your mechanical advantage. So like this, the refractive index, the specific gravity, all I hope you have come across these terms. These are all your dimensionless. That means these are the physical quantities having no dimensions. Okay. Now let us take another example, angle. Okay, angle, I hope in your maths classes you have heard many times, isn't it? What a angle is, or angle also has a special type of unit called as the radian. Okay, but although it is having a unit radian, but its dimension is 0. That means it is having no dimensions. Why? Because could you find any unit similar in the fundamental units? No, the radian is not matching with any of the fundamental units like m, l, t. So m0, l0, t0, so we'll be left with only 1. So your angle also, although it is having one unit radian, but it is dimensionless. Okay, so I hope students we have covered more about these dimensions of physical quantities.